Okay, let's go over your mock final exam number 2. Okay, I'm just going to go and read through this. A researcher is interested in learning how environmental enrichment may affect different sexes' stress response. He gathered 20 male and 20 female rats and separated them into these groups, with equal number of males and females in each group. Group A lived in a standard rat cage for 30 days. Group B lived in a bigger cage with many toys which allowed them to play for 30 days. Group C lived in a standard rat cage for 30 days, but within that 30 days, they received 1 hour of a mild electric shock, which caused them mild discomfort. And Group D lived similar to Group B, but also received a mild electric shock similar to Group C. Okay, now the researcher first measured the stress hormone corticosterone in the blood before the 30 days period. And after 30 days of the manipulation period, the researcher measured the stress hormone corticosterone again in the same rats and calculated the difference value between before treatment and after treatment period. So basically like the difference in 30 days. So the higher number indicates higher difference and suggests further departure from baseline from 30 days ago. Okay, now the following graph depicts the results obtained from this study. So the error bars is the 95% confidence interval. Okay, so that's what it looks like. Now let's go through the questions. Okay, so what are the independent variables? Okay, so the independent variables in this case is the not the grouping, okay, but the type of treatment that the different kinds of rats that they received. That's the first independent variable, okay? The type of treatment. And then the second independent variable is, you guessed it, sex, okay? Sex of the rat, okay? So number 2, what is the dependent variable? So the dependent variable in this case is the difference in corticosterone levels. Okay. And now so if you say something like stress level, that's not quite exactly the right thing to answer, because stress level is indicated by the difference in the actual corticosterone levels. Okay, so if you said if you would answer just stress or stress level, you will only get half the point in this kind. So the dependent variable is always measurable and can be operationalized. Okay, just remember that. And number 3, what is the design of the current study? Okay, so let's see. All right, so you got groupings. Okay, so that when you look at groupings, that definitely says that that is going to be between groups, right? Male versus female, that's also between groups, right? Because you cannot be male and female at the same time. So that's definitely not a repeated measure design when it comes to this independent variable either. So this is a pure between groups, what independent groups design, okay, between subjects design. And now let's take a look at the nature of the independent variable. Okay, so group A, B, C, D. Okay, so group A and B and C, they receive different kind of treatment, right? Now this is manipulated by the researcher, and therefore that part is a true experiment. Okay, now female versus male, that is not being manipulated by the researcher, but that is a subject characteristic, right? And you are picking the rats based on the sex that they were born into. Okay, so that is a subject variable that is not manipulated. So now you have a manipulated versus a quasi experiment. So that makes this a hybrid design. All right. Okay, so between subjects, hybrid design, 4 by 2. Okay, so because you got four levels and you got 2 levels in the sex. Okay. Number 4, are the independent variables discrete or continuous? Okay, group A, B, C, D, and also they got some sort of different kind of treatment, right? So the type of treatment is definitely discrete, okay? And the male versus female is also discrete. They're not on the same spectrum, but rather they're kind of dichotomous, right? Okay. Okay, now number 5, what scale of measurement is the dependent variable? Now, is there an absolute zero in this case? Because now the y-axis, later on you'll see that this is done on purpose. I did not just leave this out for no reason. Okay, so the y-axis, if you were to have the actual y-axis label, what would it say? Well, it would say something like uh, differences in corticosterone levels before and after the treatment, right? So is it possible to have absolutely no change, and that would give you a result of 0? Yes, it's possible, right? So therefore, the uh, 0 is an absolute 0, which would reflect absolute no change. Okay, so that would mean that the scale of measurement of the dependent variable would be ratio. Okay. Now, number 6, what is the ideal statistical test to analyze these results? Okay. Now, so the ideal statistical test to analyze these results would be factorial ANOVA between subjects or independent groups. Okay. Number 7, look at the graph. All right. So A, what should the x-axis label be? Okay, so the x-axis label should be the type of treatment. Okay, and on top of that, it should not be group A, B, C, D, because that does not tell you anything about what the group mean, right? Because to now because to a reader, when they're just looking at group A, B, C, D, they're like, I don't know what group A, B, C, D, what kind of treatment did they get? Okay, so definitely do not have the group A, B, C, D. So group A, you should say something like this is a control group, and then group C, group B, you should say something like this is a group uh, that were stressed. And then now let's go back. Okay, live in a big. Okay, so this is the sorry. So group B is the group that were environmentally enriched. Okay, and group C is the one that received the electric shock only. Okay, and group D is in enriched environment plus electric shock. Okay, so that is basically that's what the x-axis should say. Okay, and the label, the title for the x-axis should be the type of treatment. Okay. B, what should the y-axis label be? Okay, so the y-axis label should be, now there's nothing here. So now if you look back to the actual text, it tells you that it should be something like the difference at the end of the 30 days minus the pretest score, right? So you want to say something like uh, changes in corticosterone levels, and then you want to have the actual units. All right. All right. C. What should the title be? So the title should be, well, it should be either the effect of the independent variables on the dependent variable, or it should be dependent variable as a function of the independent variable. Okay. So you want to say something like the effect of sex and type of treatment on corticosterone level changes. So that would be one. Or you can say something like corticosterone level changes as a function of sex and type of treatment. Okay. All right. Um, now let's take a look at D. Besides the missing title, XY axis labeling, is there something else inherently wrong with the graph? And there is, okay. And that is, it should not be in a line graph. Okay, so line graph in this case is wrong. Okay, and line graph should be used in only two occasions. Um, line graph should be used when A, the x-axis is a continuous variable. Okay, so which means that, so if this is like a like amount of caffeine that is being ingested, so that would be a continuous variable. Okay, so now since the type of treatment is not a continuous variable, you really should not use basically a line graph. So that's the first scenario that you can use a line graph. The second case scenario that you can use a line graph is if this is a between subjects design. Oh, sorry. If this is a within subject design, so if this is a repeated measure design, then you can use a line graph. Okay. Now, do these data actually reflect that? All right, because it really doesn't, right? Because as we said before, group A, B, C, D, they're all discrete. This is kind of discrete data, and this is also a between subjects design. Okay, so therefore, no reason why you should use a line graph for this. Okay, number 8. Is there an overall main effect of the type of experience on stress? Okay, so now let's see the type of experience. So it's really the type of treatment, right? The same thing. So is there any differences? So now let's just take a look at the most dramatic differences, group A versus group C. So right away, you can see that group A, the changes is very little, right? And group C, the changes, well, is a lot, definitely a lot compared to the group A. So you can just say without a doubt that there is definitely a change between what like a not change, but there is a definitely a significant differences when you compare the group A and group C. Okay, so just by looking at that alone, you can say that yes, there is a significant effect of the type of experience with the type of treatment on the different corticosterone levels. Okay, so that's the first thing. Okay, now number 9, is there an overall main effect of stress? Sorry, of main effect of gender on stress? Okay, how can you tell? Now, let's just take a look at what is the difference between male and females if you were to kind of collapse all the data together. Okay, so over here, we see that there is no significant difference in group A, but in group B, we start to see a significant difference. And then in group C, we also see a significant difference. And in group D, we also saw a significant difference. Okay, so 3 out of 4 comparisons, most likely you are going to have a significant effect when you are looking at male versus female when it comes to the the corticosterone levels. Okay, so the answer is yes. All right, now is there an interaction effect? So the way that you will want to look at this is just to pick out, uh, compare like the differences between the levels. So now let's just ignore C and D. Now, if you were just to look at group A and group B alone, and let's take a look at the differences in male versus female. Okay, now male versus female in group A, they are not significantly different, right? But when it comes to the group B, what you can see is that this difference gets picked out. You start to see these differences. So that means that the effect of sex, depending on what kind of group they are, has a differential effect on the corticosterone. Okay, and when you look at the slope like this, they are not parallel, right? So that means that further is indication that this is not there is a significant amount of interaction. Okay, now furthermore, when you look at, let's say, group B versus C, you see that it kind of looks like somewhat parallel, but then you can see that the effect from B going to C, that this slope is even more augmented. Okay, so from here, you can get an idea that this is still not a parallel line, and then you can say that there is still significant amount of interaction that is going on there. So by just looking at the slope and looking at the differential effect of one independent variable in two different levels of the other independent variable, you can have a good idea saying that, okay, there is a significant amount of interaction effect that is within this group, okay, within this study, I mean. Okay, number 11. Which group has the highest variability and the lowest variability? Okay, so that the group that has the highest variability is the one with the biggest error bar. Okay, and that would be the female in group C. So basically, female in the group that received the electric shock. Okay, the one with the smallest error bar would be the one that actually has the most amount has the least amount of variability. Excuse me. So I'll say that again. So the group that has the smallest error bar will have the smallest amount of the variability, and that would be the female in group B. Okay, B is boy. Okay, now let's see. Number 12. In group A, do males and females differ in their corticosteroid levels? Group A, and group B, group C, and group D. Okay, group A, you see that the error bars overlap. They are not significantly different in male versus female in group A. Male versus female in group B, they are significantly different. In group C, significantly different, and group D, significantly different, because you see that the error bars don't overlap. Okay, that's pretty easy to see. Okay, number 13. By just looking at the graph, what does living in an enriched environment do to electric shock caused stress? Okay, do male and female respond similarly or differently? Okay, so now so basically this is asking you to look at the difference between group A and group B. Okay, so in looking at group B, well, the males and females definitely respond differently. And how can we tell? Because we see that their response here, the amount of the error bar, there are really not overlapping in male versus females. Okay, so I think that's it. But in group A, what you see is they are not significantly different. Okay, so which means that in baseline levels, they're not significantly different in male versus females, but in group B, but when they are um, dealing with enriched environment, you start to see the amount of the stress hormone goes up a little bit. Okay, well, not a little bit, but significantly from group A. Okay, now let's take a look at the next one. Okay, so male and females do not respond similar. They respond pretty differently. Okay, now number 14. What does the electric shock itself, without getting exposed to enriched environmental changes due to stress levels, do male and female respond similarly or differently? Okay, so this is basically looking at group C because this is the one that got the electric shock by itself, right? So you can see that in group C, the males and females are both really responding quite dramatically, right? So when you look at female when they're in group C versus females when they're in group A, you can see a huge rise in the differences in the corticosterone. All right, so which means that the females really respond very dramatically to the electric shock, and same thing with the males. Okay, okay, that's the first thing. Now the second thing, that just compare male versus females in group C. Okay, so you can see that the departure from the absolute zero changes in male is not as dramatic as females. Okay, which means that females have a slightly more but significant exaggeration to this electric shock when it comes to the corticosterone levels. Okay, which indicates stress levels. Okay, now let's see. Number 15. If you are the research scientist, what would you do to A, increase the internal validity of the study? Okay, so, well, the way to increase the internal validity of the study is you can maybe try to opt for just, let's say if you reduce just the male with the females, okay, then that would make it much more consistent in terms of the sex. But then then the issue is that you're basically getting rid of one of the variables. Okay, so that would be one of that's kind of like as we said before, kind of a balance between internal versus external validity, right? So another thing that you can do to increase the internal validity of the study is to make sure that there are more standardization and you hold the conditions much more constant except the manipulation. Okay, and now since sex is a variable, you might want to monitor something like the sex hormones in the mice, and then group the animals with a similar level of the sex hormones together. Okay, that you can also increase the internal validity of the study. Okay, now how would you increase the construct validity of the study? All right, so the construct validity has to do with the way that you are operationalizing the study, right? So, and it's basically just saying that we are looking at the corticosterone levels, but are we really testing how stressed out the mice are? Are we observing the behavior? For instance, for the mice, we don't really know, right? Because it's quite possible that the animals would have uh, rise, raise, or I mean, rise in their corticosterone levels, which is the stress hormone, but then they're not exhibiting signs of stress. Right. So there could be we could be measure other aspects of stress indicators, such as, let's say, changes in blood pressure, observe their behaviors and look for other aspects. Maybe look at what happens to their anxiety levels, what happens to their, are there any kind of stereotypical behaviors that you can really assess to when it comes to stress. Okay, so that is how you would increase the construct validity of the study. Now, 15C, how would you increase the external validity of the study? Well, what you can do is to really change and increase the number of the animals. Okay, so that's one. Now, since the study is on rats, what you can do is you can repeat the study on another species, as let's say mice or birds or small primates. If you have the money and if you can get this approved by the animal committee, the IOCUT committee, so these are the things that you can do to increase the external validity of the study. Okay, and now of course you cannot do this on humans for obviously ethical reasons, right? Because you cannot. Well, I mean, I'm not saying you cannot, and you should not be giving people electric shocks, right? Even if it's mild, because it causes discomfort and uh, the amount of the stress that you might be inducing in humans, uh, it's just not moral or ethical to do this. And on top of that, stress. If you want to talk more about stress research, I do this. You can definitely talk to me about it after you are done with looking at this lecture. Okay. So if there are any questions, you're more than welcome to email me. And otherwise, I think we're just going to conclude this one today.